Have you ever actually wondered what's going on inside one of these little security boxes that protect our networks? Well, today, we're going to crack open a classic, the FortiGate 60D, to show you the really clever engineering that lets it secure network traffic at just incredible speeds, and it all really starts with one big question.
Okay, picture this. You're in charge of security for a massive 10-lane highway. Every single car has to be checked for threats. Now, how in the world do you do that without bringing traffic to a complete grinding halt for miles and miles? This is the exact problem that every network firewall is dealing with every single second of every day.
And yeah, that right there is the fundamental challenge in network security. It's this constant tug of war between security and speed. I mean, to be any good at its job, a firewall has to peek inside every single piece of data, every packet that passes through. But every check, every little inspection, it all takes time. If you do it inefficiently, your super fast internet connection is suddenly going to feel like dial-up from the 90s.
So how did the folks who designed the FortiGate 60D get around this? Well, they didn't just grab a standard off-the-shelf computer processor. Nope, instead, they built a secret weapon, a custom-designed chip with one and only one purpose: to process network traffic securely and at lightning speed.
This secret weapon has a name. It's called an ASIC, which stands for Application Specific Integrated Circuit. Just think of it like this. A normal computer chip is kind of like a Swiss Army knife. It can do a lot of different things pretty well. An ASIC, though, is like a perfectly made wrench that's designed for one specific bolt. It does that one job, and it does it way faster and more efficiently than anything else out there.
And this is where it gets really interesting. On the left, you've got your general-purpose CPU, right? The kind that's in your laptop. It's a total jack of all trades. It runs your browser, spreadsheets, games, you name it. But because it has to be so flexible, security tasks can really bog it down. On the right, you have the ASIC. It's a specialist. It's purpose-built for this one job, which means it can handle way more traffic with way less effort. It's basically trading all that flexibility for raw, focused power.
All right, so to really understand how this all works inside the firewall, let's go back to our security checkpoint analogy. I want you to think of the firewall's brain as having two different people working together. There's a manager who makes all the big decisions, and then there's a team of specialists who do all the heavy lifting. So first up, we've got the manager. This is the device's main CPU, what we call the control plane. This is the brains of the whole operation. It does all the high-level thinking, setting up the security rules, running the web page you log into, figuring out what to do with brand new types of traffic it's never seen before, and logging everything that happens. But, and this is key, it does not inspect every single car on that highway. That would just be way, way too slow.
So for that, the manager passes the job off to the specialist. This is the Security Processing Unit, or SPU, and it's the heart of that ASIC. This is the data plane. These are your hyper-efficient guards at the checkpoint. They're built to handle all the fast, repetitive, high-volume stuff, like basic firewall checks, scanning for viruses, blocking intrusions and encrypting VPN traffic, and they do it all directly in hardware.
So, if you remember one thing, it's this: the manager thinks and the specialist acts. This whole division of labor, the technical term is ASIC offloading, is the architectural secret sauce that lets this firewall inspect massive amounts of data without creating a traffic jam. The CPU is freed up to just manage the system, while the dedicated hardware handles the data flow at full speed.
Okay, so we've covered the theory, but what does this actually look like when it's all happening? Let's follow a single, tiny packet of data on its lightning-fast journey from your computer through the FortiGate and out to the internet.
All right, and keep in mind, this all happens in the blink of an eye. So first, your data packet hits a port. The manager, our CPU, takes a quick look and asks, hey, is this part of a conversation I already know about? If it's brand new, the manager finds the right security rule for it. It might do some network address translation, and then it hands the packet off to the specialist, the SPU, for the heavy lifting, the security scans. Once that first packet is cleared, the manager gives the most important command: offload this. And from that moment on, every other packet in that same conversation gets to skip the line, bypass the manager entirely, and get processed directly by the specialist hardware at top speed before heading out to the internet. So that's really the magic inside this older piece of hardware. But you might be sitting there asking, okay, but why does a device like the 60D still matter today? And, what are its limits?
Well, the value of the 60D today is actually pretty clear. First off, it's a fantastic educational tool, seriously. Because its architecture is so well defined, it's just perfect for a home lab,
where you can get your hands dirty with real enterprise-level stuff like VLANs, routing, and IPsec VPNs. And honestly, for a small office or home with a pretty standard internet connection, it can still be a totally solid and reliable firewall.
But we have to be realistic here. Time and technology, they just keep moving forward. The hardware inside the 60D, as revolutionary as it was, it struggles with modern gigabit internet speeds. And its specialized chips just weren't designed for the heavy lifting required to inspect today's heavily encrypted web traffic, so its performance there is pretty limited. And maybe most importantly, it no longer gets the latest operating system and security updates, which is a big deal.
So at the end of the day, what's the big lesson from all this? The FortiGate 60D is just a masterclass in one of computer engineering's most important rules. When you have a repetitive, well-defined, high-speed job to do, building specialized hardware for it will almost always blow a general-purpose processor running software out of the water.
And that really leaves us with a final question to think about. We saw how the 60D's specialized hardware was the perfect solution for the threats of its time. But as our digital world gets more and more complex, with smarter encryption and threats that are even powered by AI, will this model of building custom chips always be the answer? Or are we going to need a whole new kind of architecture to keep our network safe in the future?